Welcome to computer graphics demo of program number 2, which is create and rotate a triangle about the origin and the fixed point. In this program, we are trying to create a particular triangle given some fixed vertices, 3 vertices whose x, y, z coordinates are given. So first we construct the triangle. Then we try to rotate that particular triangle by certain angle. The angle can be specified in degrees only. Later we are going to convert it into radians, and we are trying to rotate this particular triangle about a fixed point. Let's say some fixed point, or about a centroid of the triangle. Two options will be given. First, let's trace the program. So here we are having a triangle which is being represented in a two-dimensional array. So here we are having the points 100, 150, 200, 100, 150, 100, 1, 1, 1, 1. These points represents the x coordinate of vertex 1, x coordinate of vertex 2, x coordinate of vertex 3. Here the points are written in such a way that all x coordinates, they are stored in one particular array element, and the y coordinates of all the points are stored in another array element, and z coordinates are stored in another array element. Now let's go to the main function. So the main function, it expects the user to enter the rotation angle. So user can enter it in terms of degrees. So that has been read as theta. Then there are two choices given to the user, whether we are rotating it at a fixed point or using the centroid of the triangle, that we call it as the origin. That also we are reading it in the variable ch. Finally, we are converting that whatever the user entered angle, which is in the form of degrees, to the radians using this equation. The angle in degrees multiplied by the pi value divided by 180 degree. Later on, we have some glut initialization functions being called. Next, the important function here is the display function. Let's move to the display function. So in the display function, first we are drawing the triangle at the original, whatever the user has been specified, that particular triangle is being drawn using the two colors. Here GL color 3F is taking the three values, red, green and blue. Because red and green both are one, the color, initial color of the triangle will be the yellow color. Yellow color because the equal quantities of red and green has been mixed. Next, in case if the choice, whatever the user has given the choice as a fixed point, then we are trying to rotate that particular triangle with some fixed point. The x coordinate of that fixed point we are giving it as 100, and y coordinate of that particular triangle, the fixed point is given as 100. Then we are calling the function rotate. So in this rotate function, we are doing certain formulas here that has been explained in this particular PPT. So this is the two-dimensional composite transformation of the rotation part. Initially, in case if we want to rotate any triangle with respect to this point, first we should move that point to the origin by translation, then rotate it, again rotate it back. So after the considering the homogeneous coordinate representation, we are going to get a the composite matrix, that is cos theta minus sin theta. The last term will read 1 minus cos theta into xr plus yr sin theta. Similarly, sin theta cos theta 1 minus cos theta yr minus xr sin theta 0 0 1. So this is what is the code it is being given in the program also. Just for the convenience sake, we have included that in the PPT here. So whatever this big term we have, 1 minus cos theta into xr plus yr sin theta, the same thing here, xr and yr is having the convention as h and k. The same value is being stored in m. Similarly, 1 minus cos theta into yr minus xr sin theta, the same value is being stored in n also, and the other values cos theta minus sin theta cos theta, these are all stored in different values of the rotation matrix. Next, once we get this rotation matrix, we are going to call the multiply function. This is the matrix multiplication function. So in this multiply, so we are having the matrix multiplication part. Once the matrix is being multiplied, means here and all we have got the already the product of the three composite matrix. Now we need to multiply with the coordinate values so that we get the new points after the rotation part. So this in case of, we call this particular rotate function, then we are changing the color to only red. Initially we display the original triangle as yellow color. Now it's being displayed as red color. In case if the choice is 2, then the centroid of the triangle is given by summation of all x coordinates of all the 3 vertices by 3. Similarly, the y coordinate of the centroid is given by summation of all the y coordinates of the vertices of the triangle by 3. The same thing we compute here as h and k. Then we call again the rotate function, and then the color of this triangle is being set to 0. Then we are calling this draw triangle. In draw triangle, we are using GL begin and GL end, and we are specifying the 3 vertices in the form of matrix. And those 3 the vertices will be joined by lines using this GL triangles constant. This is how we are going to draw the particular triangle. Now let's see the demo of this particular program. First of all, the program will ask, enter the angle. So if we enter the angle as, let's say, around 45 degrees. So it is asking us the choice, whether it is fixed point or origin. First, let's try with the fixed point. So here is the point, fixed point 100, 100. Now this earlier yellow color was the triangle. When it is rotated, we have displayed it in the red color. So we are going to get like this. Now let's run this program again with the centroid. It's asking for the user to enter the rotation angle. Let's give it as 90 degree. And the choice is the origin. So now this part, the yellow color one, is being displayed, and this maroon color is being displayed, a triangle is being displayed. That is because it is being rotated at the centroid of the triangle. So we can test this particular program by changing the values of the origin, and we can also change the fixed point values, and we can also give different colors, and we can test this particular program. Thank you.